Welcome back. Welcome back. We're where the hell are we? We're on deck. All right. This is Prep Test 85, Section 2, Logical Reasoning. Let's take a shot here at question number 16. All right, so what we have, the issue raised in 16 is to weaken the argument. All right, well, so let me get my arms around the argument. More specifically, the scientist's argument. An orbiting spacecraft detected a short-term spike in sulfur dioxide in Venus's atmosphere. You stop. You get it? So it's a spacecraft, and we see a spike in sulfur dioxide. Got it. Volcanoes are known to cause sulfur dioxide spikes in Earth's atmosphere, and Venus has hundreds of mountains that show signs of past volcanic activity. Okay, so this is building to something, right? So first we have the spike of sulfur dioxide, and then we have another fact saying on Earth, volcanoes are known to cause sulfur dioxide, and Venus has hundreds of mountains that have shown signs of past volcanic activity. Got it. New sentence. But we should not conclude that volcanic activity caused the spike on Venus. So now the conclusion, which that's the conclusion, is in derogation of what preceded it. The conclusion is saying, basically those first two premises I gave you, they didn't lead where you might have thought they were going to lead, because the conclusion is that sulfur dioxide spike did not come from a volcano. So now you have to give me the reasoning. You have to tell me, so why are you saying that? And here's the reasoning. No active volcanoes have been identified on Venus. Well, that's a problem. Hello, Shelby. Welcome back, Shelby. This is Shelby. Oh, you met Shelby. Oh, hi, Shelby. Just make yourself at home. No active volcanoes have been identified on Venus, and planetary atmospheres are known to undergo some cyclical variations in chemical compounds. I got it. So you break this puppy down. The conclusion is the third sentence. The conclusion says we should not conclude that the volcanoes are the source of the sulfur dioxide. The reasoning is that final sentence, and the reasoning says we're saying that because we haven't identified an active volcano on the planet. And there are other sources for sulfur dioxide. It could be just a natural cyclical variation. So to attack this argument, you really want to attack that final sentence. That's where you're going to spend your energy. Let's see what we have here. A, conditions on Venus make it unlikely that any instrument targeting Venus would detect the volcanic eruption directly. Well, that weakens the argument. I would certainly keep reading, but if you just drill down on A, for this argument to succeed, you have to establish that no active volcanoes have been identified on Venus. That's the predicate. That's from which Zeno says, so this can't be, right? But there's no independent evidence of that, of there being active volcanoes. And A says that conditions on Venus make it unlikely that any instrument would detect it. So even if it were happening, we wouldn't know it was there. So I'll keep reading, but A is going to be the answer. B, evidence suggests that there was a short-term spike in sulfur dioxide in Venus's atmosphere 30 years earlier. Well, but this argument has to do with the spike that just occurred, not whether there was CO2 30 years earlier. And the mere fact that there was CO2 30 years earlier doesn't weaken this argument. It could be from, as the reasoning told us, from the cyclical variations in compounds. C, levels of sulfur dioxide have been higher in Venus's atmosphere than in Earth's atmosphere over the long term. That's not weakening this argument. This argument is don't attribute this to the volcanoes. And there's the third, in choice C, it's like, okay, well, we're not attributing it to the volcanoes. We're not, it's just high. We don't know why it's high. It's just high. D, traces of sulfur dioxide from volcanic eruptions on Earth are detectable in the atmosphere years after the eruptions take place. Well, one, that has to do with Earth. Two, This spike is something that we're looking at in orbit. The spacecraft saw the spike just and said, boop. So it's not something that's years out. It's the spike. and again, establishing that there are traces of sulfur dioxide on Earth many years after the eruptions take place in no way weakens the argument that the the spike on Venus was caused by a volcano. It just doesn't affect that at all. And most instances of sulfur dioxide spikes in the Earth's atmosphere are caused by the burning of fossil fuels. All of these, other than A, take you away from the issue. The issue here is, again, the conclusion is, don't conclude that the spike was the result of a volcano. The reasoning is, we haven't identified any active volcanoes. That is where your focus must be. And A casts direct doubt on that by saying, we really don't have the capacity to directly identify a volcanic eruption. So A is the answer. With respect to question number 17, they want to know what is most strongly supported by the information above. Okay, increasing the electrical load carried on a transmission line increases the line's temperature, and too great a load will cause the line to exceed its maximum operating temperature. You got to stop and say, did I get all that? So I think I got it. So first thing we're introduced to is the electrical load that's carried, all right? And what we learn is that increasing the load increases the line's temperature. I got that. And too great a load will cause the line to exceed its maximum operating temperature. So there's a relationship between the load and the line temperature, right? A direct correlation. One goes up, the other goes up. Got it. Strong winds cool the line more than light winds. Okay? Here's an external factor affecting the temperature. Not the load, but the temperature. Strong winds cool the line more than light winds do. And wind blowing across a line, this way, right, cools it more than wind blowing parallel to a line. That's it. So, okay, and you want to know what's most strongly supported. So most strongly supported is what is most judiciously drawn from that information. Okay, and you can see the connection between the wind, right, and the temperature of the line related to, of course, the load in the line. Okay, so you got load, that's affecting temperature. You got wind, that's affecting temperature. Let's see where they go with it. Hey, electrical utility companies typically increase the electrical load on their transmission lines on days on which the wind has a strong cooling effect. I have no clue when the companies increase their load. They increase their load when there's an increased demand. So you really have to stretch to say, oh yes, and the increased demand is directly related to the wind. That's not what this is. B, transmission lines that run parallel to the prevailing winds. Transmission lines that run parallel to the prevailing wind can generally carry greater electrical loads than otherwise identical lines at a right angle to the prevailing winds. No, that contradicts what they said. They said crosswinds have a greater effect in cooling the line than parallel winds. So B is not correct. C, the electrical load that a transmission line can carry without reaching its maximum operating temperature increases when the wind speed increases. Yes, absolutely. And I'd be done here. We'll keep going, but break that down. The electrical load that a transmission line can carry without reaching its maximum operating temperature increases when the wind speed increases because the wind speed cools the line. So absolutely. So again, I'm gone. You can continue, I'm gone. D, air temperature has less effect on the temperature of a transmission line than wind speed does. That's mere speculation. We're not told anything about one versus the other. And E, the maximum operating temperature of a transmission line is greater on windy days than on calm days. And no, because you can't get to the operating temperature without understanding what the electrical load is. So you forgot about the load. That does not follow, because if the load is not high, then the operating temperature of the transmission, it depends. Is the load high, or is the electrical load low? So DE is not the answer, because it depends on the electrical load. And the answer is C for Caligula. Question number 18. The issue here is, which one of the following, if true, most supports the scientist's hypothesis? Okay, kind of guess I'm going to read about a scientist and his or her hypothesis. Let's see what exciting stuff we have here. In grasslands near the Namib Desert, there are, quote, fairy circles, large circular patches that are entirely devoid of vegetation. So you stop. Can you just see them, right? See in your mind's eye, this is devoid of vegetation. Okay? Since sand termite colonies were found in every fairy circle they investigated, scientists, and here's the hypothesis, scientists hypothesize that it is the burrowing activity of these termites that cause the circles to form. You stop for a second. Look, it's the analysis. It's all Iraq. Let me do the analysis. So I know I have these circles. I know these circles are called fairy circles. And now you tell me that there's a hypothesis that the termite burrowing activity, okay, that's burrowing, causes the circles to form. So I can see the termites go down, the burrow, and they go up. Okay, I got it. And they want me to support that hypothesis. All right, bring it on. A, dying grass plants within newly forming fairy circles are damaged only at the roots. Yeah, I mean, I keep reading, but yeah. I mean, because you play that out. So we're in the fairy circle, and you have dying grass plants, but they are only damaged at the roots. Well, doesn't it sound like they're damaged at the roots because the termites are burrowing? So yeah, I mean, keep reading, but yeah. B, the grasses that grow around fairy circles are able to survive even the harshest and most prolonged droughts in the region. What in God's name does that have to do with the burrowing? C, the soil in fairy circles typically has higher water content than the soil in areas immediately outside the circles. I mean, I guess I could, wildly speculate that the burrowing would now, since water seeks the lowest level, water could get in there, but it's beyond attenuated, and A is so clear. So, no. D, fairy circles tend to form in areas that already have numerous other fairy circles. Well, that may be accurate, but that's not explaining the burrowing. And E, species of animals that feed on sand termites are often found living near fairy circles. Well, I'm sure that's a true statement, but that's non-responsive to the issue. I mean, the hypothesis is not who lives nearby. The hypothesis is how did the fairy circle form, and it was by burrowing. So E is just, okay, yeah, that's accurate, I suppose, but that's not the issue that you've been directed to address. So the answer to 18 is A for Augustus. 19. Now 19 is a little more funky, right? Because 19 you're saying, which one of the following arguments is most closely parallel in its reasoning to the argument above? Okay, so parallel reasoning, right, doesn't mean parallel structure. An argument may have fact, conclusion, fact. An argument that reasons the same way may have conclusion, fact, fact. So it's not the structure they were looking for here. It's the reasoning, the method of reasoning. So you have to read this and say, do I see the method of reasoning, right? And then in A, B, C, D, or E, can I recognize that same method of reasoning, if not the same structure, in the answer choice? Okay, so let me see if I can get the method of reasoning in 19. 19 says, Monroe was elected in a landslide. Okay, that's a declarative fact. Next sentence. It is impossible for Monroe to have been elected without both a fundamental shift in the sentiments of the electorate and a well-run campaign. This is right out of statutory construction. I mean, folks, yeah, if you're going to go to law school, this is going to be your life. If you're going to be a lawyer, this is going to be your life. All that sentence says, second sentence says, is that there would be no landslide in the absence of either of these two variables. So there's like little I and too little I, and the little I is that for that landslide to happen, it had to have a fundamental shift in the sentiments of the electorate. That's I. And then the two little I's, it also had to have a well-run campaign. It needed them both. Both were necessary. Conclusion. So it's fact. Here's the conclusion. Thus, one cannot avoid the conclusion that there has been a fundamental shift in the sentiments of the electorate. That's that first little I, and now I see the method of reasoning, right? So okay, you have two necessary conditions, and you cannot avoid the conclusion that he met one of those two. You cannot avoid the conclusion that he met each of those two, right? But here it's that he met one of the two that he had to meet. Okay. Let's see if A is parallel to that. A says, the Park Street Cafe closed this year even though its customer base was satisfied. So, I don't like that extra clause, the even though its customer base was satisfied, but okay. Okay. So first you give me a fact that the Park Street Cafe closed this year even though its customer base was satisfied. Now you give me the conclusion. So, because the customer base was satisfied, the only conclusion one can draw is that the Park Street Cafe closed because it was facing strong competition. That is not at all following the method of reasoning in the mother argument, if you will, in 19. Let's look at B. The Park Street Cafe closed this year. Declarative, straightforward. So we can conclude that the Park Street Cafe was facing strong competition. That's a different structure. That's not the way the original argument proceeded. Okay, but you tell me, you put the conclusion here. You say, so we can conclude that the Park Street Cafe was facing strong competition, since it would not have closed unless it was true both that it was facing strong competition, that's little I, and that its customer base was unsatisfied, that's too little I, and that's the answer. And to read past this is simply to abuse yourself. I mean, it's like nuts, right? That's the answer. So the way they try to throw you is by changing the structure. But if you reread this, right? If you reorient the structure, and it says, the Park Cafe closed this year. And then it said, since it would not have closed unless it was true both that it was facing strong competition and that its customer base was unsatisfied. So, we must conclude the Park Cafe was facing strong competition, which is one of the two elements. That's the answer. So I'll look at the other ones, but again, you really want to, it's so much more important for you to figure out why B is right. Once you nail down why B is right, A, C, D, and E will come more into focus. C. No one can argue that the Park Street Cafe closed this year because its customer base was not satisfied. Again, I don't like this. Okay. So if that's your initial position. No one can argue that the Park Street Cafe closed this year because its customer base was not satisfied. Even if its customer base was not satisfied, the Park Street Cafe would have closed only if it was facing strong competition. That's simply not following the same method of reasoning. D, the Park Street Cafe closed this year. Well, that I like. It's declarative. It follows. Good. All right. So the Park Street Cafe closed this year. There was no reason for it to remain open if it was facing strong competition and had an unsatisfied customer base. And see, this is nice up until now. So, one cannot rule out the possibility that it was facing both strong competition and had an unsatisfied customer base, and that is not the method of reasoning that was used. E. The Park Cafe closed this year. Again, I like that. In order to stay open, it needed a lack of competition and it needed a satisfied customer base. Hugs on all fours. Because it had neither, the unavoidable conclusion is that the Park Street Cafe could not have stayed open this year, and that is wrong. It wasn't because you had neither, and it was you had two elements They both had to be there, and therefore the conclusion is element 1 was there. And E does not say that at all. So the answer to number 19 is B for Brutus. Question number 20. Which one of the following is most strongly supported? So again, this most strongly supported is to be judicial economy. It's just to say what follows. It just flows from what I just read. Okay, so here's what we have. For pollinating certain crops, such as cranberries, bumblebees are far more efficient than honeybees. I didn't know that. Okay, but now I know it, right? So if you're going to pollinate cranberries, you want bumblebees, not honeybees. Let's find out why. This is because a bumblebee tends to visit only a few plant species in a limited area. I'm going to stop there for a second. There's a comma there. This is because bumblebees tend to visit only a few plant species in a limited area. It's like bumblebees are, they care. They're not dating all these different plants. They're very selective about their plants. Bumblebees, you can rely on a bumblebee. Whereas a honeybee, that's probably why it's called a honeybee, whereas a honeybee generally flies over a much broader area and visits a wider variety of species. So the honeybee's all over the place. The honeybee, he just flirts with everybody. If you're looking to be pollinated, the honeybee's there for you. But the bumblebee, no, bumblebee's selective. So what do you walk away with this? You walk away that, with respect to cranberries, the bee that has a limited area and visits fewer plant species is the bee that's going to be more effective at pollinating the cranberry. That's it. Let's see what they come up with. A, if a honeybee visits a wider variety of plant species than a bumblebee visits, the honeybee will be less efficient than the bumblebee at pollinating any one of those species. We have no clue about the other species. We only know about cranberries. B, the number of plant species other than cranberries that a bee visits affects the efficiency with which the bee pollinates cranberries. Yeah, that's absolutely correct, right? That's the problem with the bumblebee, is that the bumblebee is visiting a greater number of plant species and therefore is less efficient when it comes to pollinating the cranberry. So bees, again, I'm gone, but let's look at C, D, and E. The broader an area a bee flies over, the smaller the number of plant species the bee will be able to visit. I don't have a clue where that came from, because it seems beyond counterintuitive. And no, it's not the answer. D, cranberries are typically found concentrated in limited areas that bumblebees are more likely than honeybees ever to visit. No, you don't know that. You don't know that bumblebees are more likely to visit than honeybees are. It's just that honeybees, they got to go see other folks. They date a lot, And the bumblebee, it's not so much, not really all that active. Once it's it's almost monogamous with the cranberry. So no, D's not the answer. And E, the greater the likelihood of a given bee species visiting one or more plants in a given cranberry crop, the more efficient the bee species will be at pollinating that crop. Okay, so try that one again. The greater the likelihood of a given bee species visiting one or more plants in a given cranberry crop, the more efficient that species will be at pollinating that crop, and we don't know that. We don't know that the bumblebees and the honeybees, if you break them down, they may have an equal likelihood of visiting one or more crops in a given cranberry crop. The difference is, there may be 50 visits by a honeybee, there may be 50 visits by a bumblebee, but the difference is that the bumblebees visit fewer other crops, whereas the honeybees visit more crop species. So the answer to number 20 is B for Brutus, and on we go.